Hi everyone, my name is Connor and you're watching the first video of a brand new series designed to prepare you for the Math SAT. I've been a math tutor for about a decade, and I believe the best way to prepare for the SAT is to get your hands dirty with real SAT problems. So in this video series, we're going to do exactly that. We're going to tackle every single math problem on a real practice SAT. But before we do that, it's important for you to understand exactly how to study. If you've taken an official or a practice SAT before and you didn't like your score, then you are in the right place. Now, if you're serious about scoring well in the SAT and you've never even taken a practice test before, I want to encourage you to take a full-length, timed practice test before watching these videos. One important reason you do this is to find out what your baseline score is. That way, you'll be able to track your progress and know whether what you're doing is actually helping you improve your score. But there's actually an even more important reason, and that reason is when you make mistakes on a practice test, you generate a list of exactly the things you need to work on. Reviewing and understanding your mistakes is the secret to improving your score. So as you're taking your practice test, I want you to put a star beside two types of questions. Questions where you weren't confident in your answer, so for example, maybe you narrowed it down to two options and then guessed, and questions that took a lot of your time. After you score your test, you review all of the questions you got wrong and the questions you starred. And by review, I mean rework the problem, do research, look up formulas, watch videos, consult your classmates and teachers. This is by far the most important part of your practice. The reason you want to review the questions you were unsure about is because there's a very good chance that you guessed the correct answer despite not understanding the solution. You also want to review the questions that slowed you down to see if there's a faster way to solve them. The test is timed, and every minute you save on one problem is a minute you can spend solving other problems. So go take a practice test. You can download the practice test that we're about to review by visiting the link in the description below. It's Practice Test 1 straight from the College Board website. Oh, and one other thing. It is absolutely essential to attempt every problem yourself before you see the solution. Making mistakes yourself is how you grow as a mathematician. So without further ado, let's jump into it. All right, so our first question, what is 10% of 470? All right, pause the video and see if you can figure it out. We've got 37, 47, 423, and 460 as our options. Go ahead and pause the video and see if you can figure it out. All right, so the style that I like to do these SAT problems with when I'm working with students is I want to show you the way that I would think through this problem and actually do this if I'm taking the SAT, I'm back in high school, I'm trying to figure out this as fast as possible. And so I'm going to do that now. We're going to start out that way. And then if you're still confused about what is a percent even, then we're going to talk about that in more depth. So if you don't want to go through that discussion, if you know the answer, then you can skip ahead to the next problem. But if you're curious, what is even a percent, we're going to talk about that in depth. All right, so let's start out by asking ourselves, what is 10% of 470? The way that I would do that is I would say, what is 10 100ths of 470? All right, and if I'm doing mental math, if I don't have a calculator here, I'm going to take 10 100ths and convert that to 1/10. And just say, what's 1/10 of 470? And there's a trick here. When we're saying 1/10 of 470, this is 470 divided by 10. That's all that's going to be. So we're going to take 470 and divide by 10. There's a trick here. When you're dividing by a power of 10, you're just going to move the decimal places by however many zeros are after the 1. You're going to move the decimal place to the left. So the decimal place is 470 dot right here. We're going to take that decimal and we're going to move it 1 to the left. So we're going to end up with 47. All right. And I explained it a lot slower than you actually would have done it on paper. So this question should take 10 seconds at most. You get 47. All right. Now, what if you don't understand what is a percent? Well, we're going to talk about that. So if you take 470 and you divide it into 100 chunks, you want to ask yourself, what is each chunk worth? Well, if I take 470 and divide it into 100 pieces, well, we've got 2 zeros after a 1. 100 is a power of 10. We're going to divide by 100, move the decimal places 2 places over to get 4.70 or 4.7. That's how much each hundredth is worth. And I want to emphasize that 4.7 would be 1% of 470. That's what a percent means. 1% of 470 is your 4.7 value. When you divide the number into 100 chunks, what is each chunk worth? All right, so now you want to think, well, what is 10%? I'm not interested in 1%, I'm interested in 10%. So to get 10%, you would take 10 of those chunks and add them together. So this 4.7, this 4.7, and so on. 3, 4, 5, 6, 7, 8, 9, 10. That's 10 100ths. So 10 100ths of 470 is another way to look at it is you could say, well, 4.7 is 1% and multiply that by 10. Add that up 10 times and you get 47. Now we're multiplying by a power of 10. So we're moving the decimal place to the right once. So we get 47. See how useful this trick is with multiplying and dividing by powers of 10? This is really useful to know. All right. Now I want to give you another way of looking at this. Because sometimes it's going to be useful to think of this as a proportion. And I've already got some kind of solution here I'm going to get rid of. Sometimes it's useful to think about percentage problems as proportions because you may get asked a different type of percent problem. And I'll give you an idea of what you might see as another type of percent problem too, where a proportion view is going to be potentially helpful. So as a proportion, what we're doing is we're coming up with one fraction and we're saying that that's equal to another fraction. And the fractions are going to be kind of the same type of quantity on both sides. And the type of quantity that we're going to set up is the part over the whole. That's what's going to be proportional. So the part over the whole, when we're talking about 10%, is going to be 10 out of 100. The part is 10 and the whole is 100. Because out of this 100 squares, we're interested in 10 of those. So the part is 10 and the whole is 100. Now, what's the part and the whole we're interested in when we revisit this original question? What is 10% of 470? Well, we're calculating it of 470. The whole thing is 470. So on the bottom, our whole, we put 470. Now, the part that we don't know is the part. What part of the whole is 10%? So we're going to put an X here. Now, if you think back to solving proportions, there are a few ways to do this. You could cross multiply and get 10 times 470 equals 100 times X and solve that equation. That's one way to do it. Or you could simply look at this and say, well, this is X divided by 470 on this side. And to undo division, we could just multiply by 470 on each side. So when we multiply by 470 on each side, we get 10 100ths of 470, 10 100ths of 470 equals X. And that's actually, if we look back up here, that's what we got when we started this problem. We said, what's 10 100ths of 470? So this is going to be the same thing that we got, and that's going to be 47. So X equals 47. Now, why would you go to the trouble of setting up a proportion if you could just do it this way? And the reason is that proportions are going to be really useful on some of these other problems where you've got a question like, the question is 50 is 10% of what? We've asked this question in a weird way now. It's a different type of question. 50 is 10% of what? Now we want to think back to our part over whole and set up a proportion that might make this question just make a little bit more sense. So the part out of the whole on the percentage side of things is the part is 10 and the whole is 100. And that's going to be equal to another fraction of part over whole. Now, well, we don't know the whole this time. It's 10% of something. The whole is what we're missing. And now we have the part. 50 is the part of the whole that we're interested in looking for. So it's 50 is the part over X is the whole that we don't know. Now this I would solve with some cross multiplication because you would have to multiply both sides by x and then divide by 10 over 100. And so cross multiplication works really well here. 10 times x equals 50 times 100. All right, so let's simplify that. So 10x equals 50 times 100. That's 2 zeros on top of 50, so 5,000. And then we're going to divide both sides by 10 here because it's 10 times x. We're going to undo the multiplication by 10 by dividing both sides by 10. And so x equals 5,000 divided by 10 is 500. Again, move the decimal place 1 to the left. All right. And so x is 500 here. So our part is 50, our whole is 500. 50 is 10% of 500. So if they ask this type of question, now you can do it by setting up a proportion and you're not confused over what's the part and what's the whole. You're not confused over the wording of this question. You could do this using a proportion. All right, so question number 2 says, which equation has the same solution as the given equation? The given equation is 4x plus 6 equals 18. All right, so these are our choices. Go ahead and pause the video and see if you can solve this problem. All right, so this is a pretty straightforward problem if you understand how to solve two-step equations. So our equation is 4x plus 6 equals 18. And the first thing you do is you subtract 6 from both sides. And you're left with this equation. 4x equals, well, 18 minus 6 is 12. And we should actually stop right here and see if we recognize 4x equals 12 from anywhere else on this page. And if you skimmed the answer choices before you started the problem, then you'll notice that that's actually the equation listed by answer choice C. And so we're actually done. And this is a very important point. When you're doing the SAT, and the SAT's timed, you really want to save time on questions like this. Instead of actually solving for x, like dividing both sides by 4 and getting x equals 3, and then checking the solution for each one of these equations to see if it matches up, you just saved yourself maybe a minute of time doing that by recognizing that 4x equals 12 is the answer here. All right, so if you didn't know where to start with this minus 6 on both sides, that's what we're going to do now. If you understand how to solve two-step equations like this, you can go on to the next question. But for now, we're going to talk about how to solve two-step equations. Okay, so to solve two-step equations, first we've got to understand how to solve a one-step equation. So, and in order to understand that, you've got to understand what an inverse operation is. So if I've got the number 4, and I add 3 to 4, I get the number 7. Well, how would I go backwards? How would I undo this operation? And the answer to that is if you've got 7, you can subtract 3 and get right back to 4. And the same thing applies with multiplication and division. They kind of cancel each other out. If I start out with 4 and I multiply 4 by 3, then I get 12. And if I want to get from 12 back to 4, I can do the opposite of multiplying by 3, and that's dividing by 3. 12 divided by 3 gets you back to 4. So we can use this concept to solve one-step equations. So say that we've got the equation a plus 3 equals 5. Okay. So some number plus 3 equals 5. If I add 3 to a number, I get to 5. So a plus 3 is 5. Well, how would I get back to a? I would minus 3. 5 minus 3 gets you a. So that's what we've got to do to both sides of this equation. We've got to subtract 3 from both sides of this equation. And we've got to do the same thing on both sides of the equation to keep the equation balanced. So I'm going to put this in a more algebraic way. I'm going to say, whatever this number is, a plus 3, I'm going to add negative 3. That's the same as subtracting 3 from both sides of this equation. So that's going to be 5 plus negative 3 on this side. And then we're going to simplify this left-hand side of the equation. Now I've got lots of parentheses around here. These parentheses right here are telling me do a plus 3 first because this is a number and I'm adding negative 3 to this number. I've got to add negative 3 to this side of the equation too. But you can add numbers in any order you want to. It doesn't matter if you add the a and the 3 first. you could add the 3 and the negative 3 first. So I'm going to do that. I'm going to rewrite this left-hand side to say this is just the same thing as a plus, and I'm going to add 3 and negative 3 first. We could go ahead and simplify the right-hand side of this equation too. 5 plus negative 3, well, that's the same thing as 5 minus 3, and that's just 2. All right, well, what's 3 plus negative 3? Well, 3 plus negative 3 is the same thing as 3 minus 3, and that's just 0. So this whole parentheses section, we can just say that that's a plus the number 0 equals 2. There's a very important rule that you should know about adding by 0. Any number plus 0 is just going to be the number that you started with. So this is just the same thing as a equals 2. And we've solved the equation. We can do the same thing with multiplication too. We've got 4 times the number b equals 12. Then we can divide both sides of this equation by 4 and isolate b. 4's kind of cancel out because 4 divided by 4 is 1, and 1 of b is just b. And so we get b equals, what's 12 divided by 4? That's 3. So now let's combine both of these things into solving the original equation that we had. And that original equation was 4 times x plus 6 equals 18. Well, we saw in the single step equation when we had a plus 3 equals 5, in order to cancel out this 6, we added negative 6 to both sides, or you could just subtract 6 from both sides. But why did we subtract 6 from both sides and not divide by 4 first? Because a lot of people just say, let's divide by 4, and then we get, that cancels out the 4 somehow, and you get x plus 6 equals, well, 18 divided by 4, whatever that is. And that's actually not the right way to do it. To understand that we subtract by 6 first, we really have to understand the order of operations here. The order of operations says, do 4 times x first before you add 6. Because we do 4 times x first, that itself is a quantity. You can group it up, you can put parentheses around it to say we do this first. Or you can just replace that with a blank. Blank plus 6 equals 18. So some number, that was 4x, but some number plus 6 equals 18. Well, now it's obvious that we should subtract 6 from both sides based on what we did to solve the single step equation. So the 6's cancel out, and we've got blank equals 18 minus 6, which is 12. Well, what was that blank? That blank was the quantity 4 times x. And now we've got a single step equation where we've just got division. So 4 times x equals 12, we need to divide by 4 on both sides. We get x equals 3. All right, so this is our third question. The total cost in dollars to rent a surfboard consists of a $25 service fee and a $10 per hour rental fee. A person rents a surfboard for T hours and intends to spend a maximum of $75 to rent the surfboard. Which inequality represents this situation? So pause the video and see if you can solve this one. Okay, so the first thing that we need to do is we need to come up with an expression for the total cost to rent a surfboard. We need to figure out, well, how would we even calculate that? How would we even put that in the calculator and get an answer for, if we know how many hours we're going to rent this surfboard, then what is the total cost? So you could try this for, when you see variables, one thing that you could do to simplify the problem is to just put in a number for that variable and see what happens. So if you're having trouble thinking about what is the algebraic expression that I need to come up with, you could let's try out 3 for t. 3 hours. We rent a surfboard for 3 hours. So there's a $25 service fee, so we're going to have to add that on. And that's for every time we rent a surfboard. And then we have to add on for every single hour because it's $10 per hour. For every single hour that we rent it, it's going to increase our cost by 10. So that's going to be 10 for the first hour, 10 for the second hour, and 10 for the third hour. Okay, and we could come up with an answer for this. So that's a 25 and then 3 10s. So 10, 20, 30. So 30 plus 25, that's going to be $55. And we could try this for other hours, but maybe you see a pattern here. All of these 10s, we could write as, instead of 10 plus 10 plus 10, well, 10 added to itself 3 times is just going to be 3 times 10. So 25 plus 3 10s, so 3 times 10. That's another way to write this. So this is our total cost. Now we got to think back and think, well, what was T? T is in every answer choice. So T is going to play a role here in this expression. And you got to think, where does T go? Well, 3 is the number that we substituted for T. So really what we're going to write is, if we don't know how many hours we're renting it, we're just going to say 25 plus T times 10. However many hours we rent this surfboard is however many 10s we're going to add to the total price. So this is our expression for the total cost of the surfboard. Now let's take a look at the other part of the problem. So a person rents a surfboard for T hours and intends to spend a maximum of $75 to rent the surfboard. What does it mean by maximum? What does maximum mean? Well, maximum means this is the highest possible value. And it's the maximum of what? Well, it's the maximum of our total cost. Our total cost cannot exceed 75. It can't be greater than 75. Okay, so let's draw a number line and think about what kind of possibilities there are for the total cost. So 75 is, we're going to put it in the middle right here, and then 74, 73, 72, and so on. And then we got $76, $77. All right, maybe we only have $75 to spend. That's why our maximum is 75. And so what if our total cost ends up being $73? Is that okay or not? Well, that's okay, because we're saying the maximum is 75. So that's okay. Is 74 okay? Yeah, that's okay. Is 75 okay? And you always want to ask yourself, when you're coming up with an inequality, is it going to be less than, or is it going to be less than or equal to 75? Well, 75 is okay, because we're saying that the highest possible cost is 75. So 75 is okay. Now, when we get to like 76, that's not okay, because that's higher than the maximum. Even $75.50 right here in the middle, that's not okay either. So if we're graphing this inequality, then we're going to put a closed circle at 75 to say 75 is okay, and anything less than 75 is also okay. So something like that. So our total cost, and this is our total cost. Our total cost needs to be in this little green arrow somewhere. So our total cost, it's okay if the total cost is less than 75. But since 75 has a closed circle, and we're saying it's okay that the total cost is $75, it could also be equal to $75. So our inequality looks like this. The total cost is less than or equal to 75. And what is our total cost? Well, we've got an expression for the total cost up here that we came up with up here. 25 plus T times 10. So 25 plus T times 10 needs to be less than or equal to 75. And that's our inequality. So now it's time to go back to the answers and see if there's anything that looks close to what we have. A doesn't look close. B looks close, but if we look carefully, it's a 10 here instead of a 25, and it's a 25 times T instead of a 10 times T. So that's not it either. 25T is less than or equal to 75, that's not it. Well, if we look at D, D looks pretty close. We've got 25 plus T times 10 Is that the same as 25 plus 10 times t? Well, 10 times t is the same as t times 10. It doesn't matter what order you multiply numbers in. So we could write this as 25 plus 10t. 10 times t is less than or equal to 75. And that's equivalent. So that's our answer. D is the answer. All right, that brings us to our next question. Question number 4. All right, question 4 says, the function g is defined by g of x equals x squared plus 9. For which value of x is g of x equals 25? All right, pause the video and see if you can solve this one. All right, so if you couldn't solve this one, a lot of it could be due to the fact that the way this question is worded, this is a very mathy worded question. The function g is defined by blah, blah, blah. For which value of x is g of x equals 25? So my goal with this part of the video is to hopefully teach you how to read math like this and teach you what a function is if you don't know what a function is. And hopefully that gives you a better idea of how to approach this problem, how to even read this problem. Okay, so we're going to start with talking about what is a function. So what is a function? Well, a function, it's simply a rule that takes an input and gives an output for every number that you give it. So here's what I mean by that. So I'm going to give you an example of a function. So a function, let's say that our function, we give it for an input, we give it 1, and it goes into this machine, this function. I'm not going to tell you what this function does, but if you give it a 1, it spits out a 3 as its output. If we do the same thing with a 4, if we feed a 4 into the machine, this function, I'm going to tell you that this function outputs a 12. And if we give it a 7, we put a 7 into the machine, it outputs a 21. There's a rule that I haven't told you what this rule is, but there's a rule that takes an input and gives you an output. And I want to see if you can pause the video and think about what that rule might be. All right. Now, the rule that I had in mind is that this function actually takes the input number and multiplies that number by 3. So this function just simply multiplies the input by 3. And so if you know the rule, then you can predict if a 10 goes into this machine, you can predict what's going to be output. Well, what's going to be output is a 30 because 3 times 10 is 30. All right. So let's talk about the mathy part of this, and that's this whole function notation. Like, how would we actually write down what this rule is for this function? Well, the way that you do that is you have to come up with a name for your function. First of all, I'm going to call this function that we're defining f. So this function, actually, I'm just going to write f here. F. And so to define the function, I'm going to write f parentheses x. And the way that we read this is actually not f times x like you might be used to. This is f of x. That's what we say, f of x. F of x equals, x is our input. Whatever is on the left-hand side of this is our input number. And the rule for the output is 3 times whatever that input is, so 3x. So to review, f is the name of the function. Name of the function. X is our input. And our output is 3 times the input. So here's how to evaluate functions. So evaluating a function is plugging in the input value and seeing what the output is. And so an example of this would be f of 1. F of 1 means plug in 1 as the input value everywhere you see x, because x is what we're calling the input. So 3 times 1, we get 3. And that captures what's going on here in this first little diagram. When we plug in 1 to our function, we get an output of 3. F of 4, well, we plug in a 4 wherever we see x up here in our definition for our function. So that's going to be 3 times 4, and that's going to give us 12. All right, so let's go back to the question at hand. Now that we know what a function is, and this function notation, hopefully we've demystified it for you. The function g is defined by g of x equals x squared plus 9. So I'm going to write that definition here. G of x equals x squared plus 9. And if we revisit our little diagram notation, that means that when we have a number called x as input into our function, g, then our function is going to give us as output x squared, whatever that number was, x squared plus 9. All right, so we can do this for an example number. We could calculate what is g of 3. So when we put a 3 into our function g, what does it give us as output? So pause the video and see if you can figure out when you input 3 into this function g, what does it give you? So if we plug in, for x, if we plug in the number 3, then we get 3 squared plus 9. And that's going to give us 3 times 3, right? 3 squared is 9, and then 9 plus 9 is 18. So g of 3 equals 18. We could write that simply as this little equation right here. But the other mathy part of this question is this sentence here. For which value of x is g of x equal to 25? So let's write that down. G of x equals 25. And let's try to figure out what this even means. G of x equals 25. Remember, x is a variable and it's the input variable. And what this question is asking is, what would you plug into x here to get this equal to 25? We know it's not 3 because g of 3 equals 18. So it's something else. So pause the video and see if you can think of a way to complete the rest of this problem knowing what we know. All right, so the approach that I'm going to take you through is the way that I would probably do this problem. And it's because it's so easy to plug in for x. If you can do quick mental math or you're quick with your calculator, you can really just start by plugging all of these values in because it gives us all of the possibilities. X could be 4, 5, 9, or 13, according to these answer choices. So I'm just going to start with 4 and see if it works. What's g of 4? We want that to be 25. Well, if we plug in 4 here, 4 squared plus 9, 4 times 4 is 16, and 16 plus 9 is 25. And we've solved the problem. We didn't have to try 5, 9, or 13. And it's really quick to do this. If you're good with your mental math or you're good with your calculator and you could do this quickly, then you can come to the answer really quickly. The answer is A. Now, one thing you might say is, Connor, this could be a free response question. These answer choices might not even be here. So if they weren't here, let's see how you would solve this problem if you didn't have the answer choices. So if that were the case, the way that I would solve this problem is by seeing, well, where does this expression equal 25? So I need x squared plus 9 to equal 25. And I need to figure out what x is. And now we've got an equation that we can use our standard algebra procedures to solve. So how would you solve this equation? Well, the first thing you would do is notice that the exponentiation is really glued to the x, so we need to break off this plus 9 first. We need to undo the plus 9 by subtracting 9 from both sides of the equation. And we get x squared equals 16. Now, you might be told, okay, I need to take the square root of both sides of this equation. But I want you to see if you can think about what squared gives you 16. And you might realize that 4 squared gives you 16, but there's actually another number that when you square it gives you 16, and see if you can figure out what that number is. So that other number is negative 4, because remember, negative 4 times itself, well, negative times a negative is a positive, so you get 16 this way. So that is the other solution to this equation. So we actually have to write x equals plus or minus square root of 16. So that's x equals plus or minus 4. Since there are two solutions to this equation, we actually have g of 4 equals 25. Because when you plug in a 4 here, you get 25. 4 squared is 16 plus 9 is 25. But you also have g of negative 4 is 25. So the bottom line is that, well, they wouldn't make this a free response question because there are actually two solutions that you could give. And if they did make it a free response question, then what they would ask is, well, give me the positive answer, or give me the negative answer, or something like that. If they said, give me the positive answer, then you would put a 4 for your answer. All right, so hopefully this gives you an idea of how you would solve this if it were a free response question too. All right, so question number 5. Each phase of a fair 14-sided die is labeled with a number from 1 through 14, with a different number appearing on each face. If the die is rolled one time, what is the probability of rolling a 2? We have 1 14th, 2 14ths, 12 14ths, and 13 14ths. Pause the video and see if you can solve this one. All right, so this one is straightforward if you know the definition of probability. So if you don't know the definition of probability, that's what we're going to explain here. So probability is equal to, well, probability is simply a way to quantify how likely a scenario is. You know, you have something random happening, like we're rolling a die and we don't know what's going to happen. And we make some assumptions like, well, every number has about an equal chance of appearing when we roll the die. And so under those assumptions, we can make this following fraction. So the probability is equal to the number of ways something can happen. Something can happen divided by the number of total possibilities. And so when you get a fraction like this and you do it right, then you end up with a number that's on the number line is between 0 and 1. It could be 0 or it could be 1. You end up with some fraction in this range here. 1 14th is really close to 0. And 13 14ths is really close to 1. And we say 1 is certain and 0 is not possible. So 0 means that something is not possible and 1 means something is absolutely going to happen. And then somewhere in between is, well, somewhere in between. If it's close to 1, that means it's like really likely going to happen. And if it's close to 0, that means that it's probably not going to happen. And right here in the middle would be 7 14ths or 1/2. That's 50%. It's a coin flip. It could happen or it could not happen, and it's equally likely. All right. So let's count the number of ways that this thing can happen. So we're rolling a fair 14-sided die. To be fair, I've never seen a 14-sided die. But we have to assume that this is possible. So we've got a 14-sided die. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Those are all of our possibilities. We've enumerated all of them. And so we know the bottom part of this fraction. What's the total number of possibilities? So the probability is equal to, well, something over 14, because 14 is the number of possibilities that exist. And all of these possibilities are supposedly equally likely because we're rolling a fair 14-sided die. All right. Now, what's the number of ways the thing that we're interested in can happen? Well, the thing that we're interested in is rolling a 2. That's the event. How many ways can we roll a 2? Well, there's only one way we can roll a 2. We roll a 2. Any other number would be not rolling a 2. So there's only one way we can roll a 2. So we write 1 here. So the probability, if you did it correctly, is 1 out of 14. We have a 1/14th chance of rolling a 2 on a fair 14-sided die. So that's our answer. Now, in this example, we only had one way that the thing that we're interested in can happen. A more complicated probability question would be something like, well, what's the probability of rolling an even number? Probability of rolling an even number. Our event here now has multiple outcomes that could trigger this event. Not only would a 2 trigger this event, but also a 4, a 6, an 8, a 10, a 12, or a 14. So the probability of rolling an even number would be, well, there are still 14 possibilities. And of those possibilities, 1, 2, 3, 4, 5, 6, 7 of them are when you roll an even number. So the probability of rolling an even number would be 7/14, or if you simplify this fraction, that's 1/2, or 50%, or 0.5. On the number line we're looking at between 0 and 1, 1/2 is smack dab in the middle. And so this is a coin flip. All right, so we come to question 6, and this is the last question we're going to do today. A printer produces posters at a constant rate of 42 posters per minute. At what rate in posters per hour does the printer produce the posters? And we don't have any answer choices for this question, so we're going to have to come up with a number and enter it ourselves. So pause the video and see if you can come up with that number. Okay. So there are a couple ways to do this problem that I can think of that are both, I think, equally valid and just as fast as the other. And I want to give you both of those just to give you multiple ways of doing things. Okay, so the first way that I can think of is, well, think of it a minute at a time. 42 posters per minute means that every single minute you're producing 42 posters. So in the first minute, minute 1, how many posters did you produce? 42. In the second minute, minute 2, how many posters did you produce? You produced 42 posters. And you could keep going with this. I'm going to write ... to say I'm going to omit, I'm going to leave out a bunch of these minutes, and I'm going to eventually get to the 60th minute, right? Because there are 60 minutes in 1 hour. So minute 60, I also produced 42 posters. All right. Well, when you add up all of these 42s, you take this minute's 42 plus this minute's 42 plus all of these plus the 60th minute's 42, you get the number of posters that you produced in a single hour. And so it would be 42 plus 42 plus 42, but you're not going to do 42 plus 42 plus 42 on your calculator. You're going to figure out a faster way. If you know what multiplication is, you know how to do this faster. It's just 42 times 60. So 42 times 60 gives you the number of posters that you produce in an hour. And so that's going to be 2,520 posters. All right. That's one way to do it. Another way to do it is using this technique called dimensional analysis. All right. So the answer is 2,520 posters. Let's see if we can come to the same conclusion using dimensional analysis. All right. So using dimensional analysis, we're going to basically create fractions of units and come up with some ways to cancel those units to get the units that we want. And so it's going to make more sense when we actually do this. So we've got our 42 posters per minute. Per means a fraction sign. Per means division. So 42 posters per, our fraction here, per 1 minute. Posters per minute. And we're going to multiply that by some conversion factor. And our conversion factor, we're going to think about what the units on that conversion factor need to be by looking at the fraction that we want. So this times something, some other fraction equals, we want to end up with posters per hour. So it's going to be posters on the top and then hour or hours on the bottom. We want to end up with this. All right, so what do we need to do what do we need this fraction to look like in order for us to multiply this fraction with this one in order to end up with posters and hours like this? Well, we've got to cancel out minutes. So we need minutes up here. And these, when we multiply them, the numerator and the denominator here, these units are going to cancel out. And if we have hours on the bottom here, then we're going to have posters over hours on the right-hand side of this equation after we cancel everything out. So we need to figure out, well, how many minutes are in an hour? Well, we already know that. 60 minutes are in 1 hour. So you could write 60 here and write 1 hour here. 60 minutes per 1 hour. All right, and now that all of our cancellation works, we should multiply these fractions across, because that's how you multiply fractions, right? You multiply the numerators together and you multiply the denominators together to get your denominator. So to get to the numerator, we got 42 times 60, which actually is exactly what we did here. That's 2,520. And our denominator is 1 times 1 to get 1 here. 1 hour. All right, now there's danger here in that it wants the unit rate, posters per single hour. If we had 2 or 3 or 4 hours down here, then we would need to divide 2,520 by the number here in order to get this as a unit fraction. All right, and that would be the number that we come up with. So really, we should, to be safe, we should do 2,520 divided by 1 to get our unit rate of posters per hour. And well, anything divided by 1 is not going to change the number. So we just end up with 2,520 posters per hour. And that's our unit rate. And that's actually the same thing that we got here. So this is the way using dimensional analysis. And I would think dimensional analysis here might be a little bit overkill. If you can see how many minutes are in an hour and then do this multiplication quickly, then you can really quickly come to the answer. But dimensional analysis is a really powerful tool that you can use on these really complicated questions when you've got something like, I don't know, 42 posters per every 29 minutes or something like that. And then dimensional analysis comes in a lot more handy here. All right, folks, that's all I have for today. But if you're excited to see more, please like, comment, and subscribe. It'll really help out the channel and get these videos to people who need them. All right, see you next time.